Around 424 million years ago, a small organism called a graptolite drifted through the seas, unaware of how important it would become to scientists. Though only a few centimeters long, graptolites played a big role in uncovering the mysteries of the Silurian period. For a long time, scientists believed the Silurian was a peaceful time, where life was recovering after mass extinctions at the end of the Ordovician period. Fish, cephalopods, and sea scorpions roamed the oceans, while the first plants and arthropods slowly took over the land. The climate seemed perfect for this growth, with warm seas supporting ocean life. But that idea of the Silurian turned out to be wrong. Graptolites tell a different story, one of huge changes in the ocean. There were times when the oceans became poisonous and suffocating before clearing up again. These changes caused extinctions and recoveries that scientists didn't expect. Most importantly, graptolites showed that the Silurian period was unpredictable. Graptolites first appeared in the Cambrian period over 500 million years ago. Their fossils are flattened tubes with openings that once held colonies of tentacled polyps, like modern-day coral. Though graptolites are extinct today, their relatives, the terebranchs, give us a clue about how they lived. Both graptolites and terebranchs are filter feeders, using tentacles to catch plankton. By the end of the Cambrian period, graptolites gained a key advantage: they could move. Around 485 million years ago, they lost the hold fast that kept them fixed to the seafloor. This allowed them to float in the ocean, spreading faster than species stuck to the sea floor. They may even have used their tentacles to help them move. These free-floating graptolites became more symmetrical and cone-shaped, making them stable in ocean currents. They adapted to living in deep ocean water, feeding on plankton as they floated. Graptolites are important to scientists because they can help track changes in the ocean. In the 1990s, researchers noticed odd patterns in the Silurian rocks of northern Europe. There were periods when graptolite species would go extinct, only to be replaced by others. The fossils showed these changes matched shifts between deep-water and shallow-water deposits. These shifts indicated something big was happening in the oceans. The changes took place over periods of 10,000 to 200,000 years. Scientists realized this pattern was also found in other marine creatures like conodonts and brachiopods. These ocean changes were called primo episodes and secundo episodes. During primo episodes, the ocean had cold water at the poles and warm water near the equator. This caused mixing, which kept oxygen in the water. But during secundo episodes, the ocean stopped mixing, and the bottom layers became anoxic, meaning they lost oxygen. These changes happened at least 15 times during the Silurian, and scientists aren't sure what caused them. Some believe changes in Earth's orbit might have played a role. The Silurian was different from today. There were no plants on land, so erosion happened quickly, and dust storms may have added nutrients to the oceans, further changing the environment. These factors likely caused oxygen loss in the water, especially at the bottom. When the water lacked oxygen, it became toxic with hydrogen sulfide, which some bacteria produced. But graptolites thrived in these low oxygen, warmer conditions. They lived in deep waters, where they were less